Introduction. If you only had a few minutes to understand AI and UX, why artificial intelligence needs user experience, this is the video you need. Let us unpack the ideas that matter most. Here's what is coming up: a quick overall summary, then a section-by-section breakdown of the most important points. Overall summary. User experience. Don Norman coined the term user experience in 1993, while working for Apple. Definition: user experience, or UX, asks designers to look at new technologies as experiences, not products. When one focuses on the user experience of a product, the interaction design needs to do much more. This framework is rooted in classic user-centered design where the user is at the center, not technology. The point: sometimes the design for design's sake can get in the way. His work was foundational for computer science, AI, and UX. Chapter 1: User and Experience. But its potential is dependent upon having technology work. Because when technology does not work, there are consequences. They defined AI as making a machine behave in ways that would be called intelligent if a human were so behaving. Machine learning is often a central part of AI, but it's fairly rare. The emergence of artificial intelligence is closely timed with that of user experience, both coming at the advent of the computer age. Don Norman coined the term user experience in 1993, while working for Apple. In a video for his research organization, the Nielsen-Norman Group, Norman describes user experience as a holistic concept, incorporating the entirety of an experience of buying and using a product. Point 6: He presents the example of purchasing a computer in the 1990s, imagining the difficulty of lugging the computer box into one's car and the intractability of the computer's setup process. This reveals the all-encompassing nature of user experience. User experience, or UX, asks designers to look at new technologies as experiences, not products. The Ameritech slogan represented the work of a small team of 20 human factors engineers and researchers managed by Arne Lund. Arne was a mentor to us, the authors, and to dozens who learned under his leadership. We saw the evolution of human factors to user experience while working for Arne. The role of this team was to make products work for the user. But the key is not whether they work for an engineer, but for the user, someone who bought the product or possibly received it as a gift. The Ameritech slogan encapsulated the research and design that was needed, not simply to integrate technology into new products but to transform experiences for people as a critical criterion of success. Incorporating a user-centered approach was not the norm in 1995. If AI doesn't work for people, IT doesn't work. Gavin, the human factors team at Ameritech, under Arne Lund, was an amazing group at a special time. For me, it was my first experience applying psychology, research, and user-centered design to make positive changes in a product. The point: product developers increasingly recognize that good design matters. Understanding how people interact is critical to product success. When you think of a user experience, consider adjectives and adverbs that describe the interaction, such as in Figure 1.1. But we argue that a product's success tends to need more than a satisfying experience. These are the descriptors that make a user experience great. These UX adjectives and adverbs raise the bar for an experience of a product beyond satisfying. Chapter 2: User and Experience. UX is our area of expertise, and the thesis of this book is to propose applying UX principles to the design and development of user interfaces to artificial intelligence applications. At this point, we posit that an essential element in AI's success hinges on understanding and improving the user experience, not on giving AI all manner of new functions. Having a good initial experience goes a long way. So much time and effort goes into product design. Gavin, yeah, think of voice-enabled calling in a car. Fool me twice, shame on me might apply to human interactions, but human-to-AI interactions is more like, fail me once and you tend to not try again. Gavin, applying this logic to all the technology around us, this need for a good user experience goes beyond voice calling. Think about the effort that goes into the design of the 500+ features in a BMW 540, for example. Once accessed, does the feature map to how people expect it to work? Understanding how users will interact with this output is the experience. The point products embedded with new technology do not automatically ensure success. A positive interaction is essential. The UX framework is our method of considering user experience while designing an AI application. Improving health outcomes is the goal, not whether a computer's recommendations correlate to a human. The point: we limit AI by determining success on whether its outcomes correlate with human outcomes. Let us take control and design a product with AI as a team. Gavin's college roommate at the University of California, San Diego was Craig Neese, who studied computer science. That additional interaction with the user makes a world of difference. Interaction refers to AI engaging the user in a way in which they can respond. While this request for user consent is not foolproof, e.g., perhaps the user's phone has been stolen alongside the card, or it is out of battery, it works better than the old method of giving the user a phone call. Before AI takes a potentially impactful action on a user's behalf, it should attempt to interact with the user. Unexpected outcomes can include performing additional, unnecessary or unhelpful tasks that the user did not ask for, or breaching the user's privacy in a way that the user could not have anticipated. Siri is one of many voice assistants that listen for spoken commands. The voice assistant recognizes phrases and processes the information. A voice assistant, or virtual assistant, is an AI-based program that allows users to interact with an application through a natural language interface. Think about the Siri experience, which is entirely independent of a screen interface like one on a TV. Chapter 3: Computer and Human. BOB. When things work well or the experience is good, one forms a feeling of trust. And when the voice dialogue on Siri does not work, what happens next? BOB. And with a voice assistant, the feeling can be persistent. Trust is vitally important to user adoption, and it's easily lost. Developers need to be careful to design an experience that engenders trust. Recognition of the power affordances have to provide information to the user is woven into the design of the product to improve usability, function, and use. Design needs to recognize the many ways that a user might use a feature. Gavin, sometimes the user's needs can come in conflict with the aspirations of the designer. Design needs to work for the whole user, not simply what the eye sees. I'm going to turn on my computer and point and click my way through a complicated task. Voice interfaces are the obvious one, thanks to the virtual assistant. The Point UX describes the holistic experience of interacting with a product. We will also take a look at some of the psychological principles underlying human-computer interaction, a key component of interaction. UX is a relatively modern discipline with its roots in the field of psychology. As technology emerged, it became known as the field of human-computer interaction, HCI. HCI is about optimizing the experience people have with technology. It is about design, and it recognizes that a designer's initial attempt on the design of the product might require modification to make the experience a positive one. In 1950, Turing proposed a test to determine whether a computer can be said to be acting intelligently. He felt that an intelligent computer was one that could be mistaken for a human being by another human being. His experiment was manifest in several forms that would test for computer intelligence. The clearest form involved a user sending a question to an unknown respondent, either a human or a computer, which would provide an answer anonymously. The user would then be tasked with determining whether this answer came from a human or from a computer. The Turing test is a procedure intended to determine the intelligence of a computer by asking a series of questions to assess whether a human is unable to distinguish if a computer or human is giving responses. Point 1. The Turing test has become a defining measure of AI, particularly for AI opponents, who believe that today's AI cannot be said to truly be intelligent. On face, Duplex engaged into a conversation with a human where the human does not appear to realize that a machine is operating at the other end of the call. Chapter 4: Machine and Translation. Gavin, the Turing test has captured the attention of the masses interested in the future of AI. The Turing test has an inherent simplicity as a game of imitation and asks the question, can a computer fool a human? Gavin, Turing's influence on computing and our perception of intelligence is undeniable, that's for sure. This might be too limiting to where AI that complements human decision-making would be undervalued. The point: this conversation between the user and the program left an impression that Eliza embodied human-like intelligence. Because the dialogue felt natural, the computer must be intelligent. Is all that is necessary for intelligence is to fool a human? But because the program felt human, intelligence was bestowed to it. With Eliza, the hype was brought about from the users. Machine translation's paramount example is the now, famous Georgetown IBM Experiment 10, where in a public demonstration in 1954, a program developed by Georgetown University and IBM researchers successfully translated many Russian-language sentences to English. A number of headlines: the bilingual machine, for example, greatly exaggerated the machine's capabilities. Point 11. This coverage was accompanied by massive investment, leading to wild predictions about the future capabilities of machine translation. The reality was far different. The machine could only translate 250 words and 49 sentences. This very early public test of machine translation featured AI that seemed to pass the Turing test, but that accomplishment was deceptive. Don't believe that the power of computing can overcome all. Gavin, the Georgetown IBM experiment was a machine language initiative that started as a demonstration to translate certain chemistry documents. And this resulted in investment that spurred a decade of research in machine language. The point: we must not believe that the power of computing can overcome all. But the technology wasn't ready to match the hype. Nearly 60 years later, machine translation is still considered imperfect at best. 19. Hype can play a large influence on whether the product is judged a success or failure. In a key portion, the report used the Georgetown IBM experiment as evidence that machine translation had not improved in a decade's worth of effort. That said, Hutchins defined the original Georgetown IBM experiment as not an authentic test of the latest machine translation technology but as a spectacle intended to generate attention and funds. Even though machine translation may have actually improved in the late 1950s and early 1960s, it was judged against its hype, not against its capabilities. As machine translation was one of the most important early manifestations of AI, this report had an impact on the field of AI in general. The first AI winter followed the ALPAC report and was associated with a governmental stop to funding related to machine language efforts. Chapter 5: Siri and Computer. The ALPAC report pulled no punches and led to a collapse in any research in machine translation, a domain-specific AI winter. Huge hype for machine translation turned out to be misplaced, and the result was a significant cut in funding. Yes, funding requests with the terms machine translation or artificial intelligence disappeared. Gavin, the first general AI winter formed a pattern of initial signs of promise, to hype, to failure, and subsequently a freeze in future funding. Notable examples are the European Strategic Programme on Research and Information Technology, the Strategic Computing Initiative, and Microelectronics and Computer Technology Corporation in the United States. Consider Apple's voice assistant, Siri. Look, to the Siri fans out there, Apple did an amazing job relative to previous voice assistants. Gavin, and Siri was the first ever virtual assistant to achieve major market penetration. Gavin, Apple hyped Siri for its ability to understand the spoken word, and Siri captured the attention of the masses. Gavin, in speaking to Microsoft Cortana design and development teams, they would vociferously argue how much different, or better, their voice assistant Cortana was from Siri. But because of the failure of trust, people who used Siri tended to associate the technology with Cortana. Unlike Siri, Cortana was a vastly capable virtual assistant at its launch, especially for productivity functions. Moreover, interaction also became a problem for Siri. Gavin, but look what it took for the masses to try another voice assistant. The Fire had a voice assistant feature, and Amazon's Jeff Bezos did not want to make Alexa's voice assistant an MVP version. 36 The point Alexa emerged as a voice assistant and broke out of the AI winter that similar products could not, but it needed an entirely different form factor to get users to try it. And when users tried, Jeff Bezos was determined to not have users experience an MVP version, but much bigger. Lick worked at MIT's Lincoln Labs and started a program in the 1950s to introduce engineering students to psychology, a precursor to future human-computer interaction, HCI, university programs. Human-computer interaction is an area of research dedicated to understanding of how people interact with computers and the application of certain psychological principles to the design of computer systems. Once there, Lick fully embraced his new career in computer engineering. Lick was the first person to merge principles of psychology into computer science. The point Lick formed the basis of where AI is headed today, where AI and humans are complementary. Taylor had been greatly influenced by Lick's ideas in man-computer symbiosis and had a similar DNA to Lick's, from psychologist to psychoacoustician to computer scientist. Closing. That brings us to the end of our review of AI and UX: Why Artificial Intelligence Needs User Experience. Thank you for listening. If you found this helpful and would like more book summaries like this, please subscribe to the channel and turn on notifications so you never miss a new video. Tell me in the comments which book I should review next, and I will see you in the next one.